Okay, so today is going to be our last sort of our tutorial session. We wrapped up talking about data frames at the end of class last time, and today we're going to go into a little bit more detail about some sort of parsing things that you can do and some packages beyond the base one in order to help parse some of the tables with capabilities that are a lot harder to do in the base version. And then we'll go over some plotting commands and visualization in R as well. Okay, so the first thing I want to talk about is merging or joins. So let's suppose we have a table with two columns, X and Y, and let's just say A, B, C, D. And here we'll have 3, 4, 5, 6. So these could just be, right? X would be a column of characters and Y would be some column of numbers. And I have X and Z in table B, and here we have C, D, E, F, and 7, 8, 9, 10. So the concept of doing a join or a merge is something like this. I'll have this Venn diagram here. Table merging. And we could have a couple different things happening. Get some more colors out here. Okay, so we can have let me actually write down. So this is table A and table B. So there is some sort of intersection between these two if we're considering, for example, joining on this column with the same name. So you can have something like this. So this would be known as a left join. You could have something like this. That would be a right join. We could have just the intersection, and this would be known as an inner join. And the last one we can have is where you keep all of the information. And this would be known as an outer join. Okay, so what does this look like if we were to perform each of these procedures on these tables? Okay, so for the left join, that means I want to keep everything from table A. So I'm just going to go ahead and draw that here, X, Y, Z, and A, B, C, D, A, B, C, D, 3, 4, 5, 6. Okay, so what do you guys think will happen here? Any guesses? Yes, exactly. So here, C and D will be 7 and 8. And then these two will just be NA like this. Okay, so hopefully you guys can kind of see what's happening here. So X, Y, Z. Here we'll have a right join, which means we keep everything in table B. So this is going to be C, D, E, F. Or my Z column will be 7, 8, 9, 10. And the only thing that I'm going to keep is my CD values here, which will be 5, 6, NA, NA. Okay, so the inner join, right, is just going to be the intersection here. So we'll have X, Y, Z, and this will be CD, 5, 6, 7, 8, which leaves my last one, which will contain everything. Okay, so X, Y, Z, A, B, C, D, E, F. So here's going to be 3, 4, 5, 6, NA, NA, like this. Okay. Hopefully everyone can see that. So this is very common sort of procedure. Let's say you have two different types of data sets where both of them kind of contain information on something that you want to look at. You can combine them using this procedure where we sort of match up some kind of reference column. And then it allows you to sort of join data together, and depending on what you're going to do, these kind of forms are all going to be pretty useful. The left and right join are basically the same thing. You're just specifying sort of which one you want all of. And the inner and outer joins will be pretty useful as well, depending, again, on the context of what you're doing. Okay, any questions about merging or joining? Okay, so I'm going to show how we go about doing that in R. Okay. So let's grab this, move it over. And we'll do, yes. Oh yeah, sorry, let me, okay, yes, it's the one on the far left. I would just turn it off. There you go, nice. Okay. All right. Can everybody see? I know there were some text size issues last time, so I'm trying to make the font a little bit bigger. Okay, so let's just replicate this exactly. So we have table A, and we'll just define this in the same way that we did last time. So I'm going to say X is equal to C, A, B, C, D, right? So A, B, C, D, comma, Y is equal to, I'm just going to use that shortcut, 3:6. Okay, so I should be able to run that, and it makes a table A. Table B, we'll do the same thing here. X is equal to C, D, E, F with y equal to, or sorry, Z equal to 7:10. Okay, so if I run that, oh, mistake already. Oh, I used periods instead of commas. Off to a good start. All right, so let me let's take a look at our table A's and B. So table A, so you can see here, should match exactly this here, and then table B should do the same thing. Great. So now let's take a look at how to join these guys together. So we'll go through each of the different merge options. So left join, I'm going to make a new table. And the way that we do this in R is using a function called merge. So the inputs for merge, you'll have an X and a Y, and those refer to the two tables that you want to merge together. So here I'm going to have table A, and for Y, I'm going to have table B. Okay. You then specify which column is your reference column in the two tables. So that's just doing by equals, and then you have to have a parentheses, or sorry, a quotes for the column name that you want to look at. So quick note, if you have two tables where the column names that you want to join are different, you can still handle that. You can either change the name before you do this merge, or in the merge itself, you can have a, so okay, to join tables with different column names, use by.x equals and by.y equals instead of by. So basically on line 5, I have by equals x. Let's just suppose this is, let's suppose this is x and this is f. You would do by.x equals x and by.y equals f. Okay. So let's take a look at what happens. Okay, so, oh, sorry. I wrote left join, but this might not give us left join. So I'll rewrite it in just a second. Okay, which join is this? Left is inner, right? We can see here, it only gives CD 5, 6, 7, 8, inner join. So let me change the name of this from left join to inner join so as not to cause any confusion. 1, 2, 3, 4. Okay, so this is actually the inner join. So the default behavior for merges will just try to do the complete sets of both tables. So it's going to do this green thing, right? Your intersection of the two tables. So how do we do the other types? So the outer join, we do, and actually I'm just going to copy and paste this. It will be faster. So at the end of this, there's an additional thing you can specify, all I do is all equals true. Okay, so the default way it fills out the function, it says all equals false, but I can specify this, and this will create, hopefully, the outer join. So if we take a look at what happened, okay, great. We can see here A, B, C, D, E, F, right? So this is our purple one here that gives all of the information. And then for the ones in the corresponding tables that don't have those values, it fills in NA, as you can see here. And let's take a look at the left and right join. So left join, pretty similar. Instead of all equals 2, I'm going to do all dot x equals true, referring to, right, our table x, or the x object, which is table A. And it basically says take all the values from there. So we should expect the left join here, which is this table in blue. So everything from x, and then NAs for the non-matching values in table Y. So left join. Great. So we've got that. Let's take a look at the last one, which is the right join. By now, you should get a hang of what is happening here. So we'll just say all dot y is equal to true. And if I run that, we should get our last table. And there you see, that matches our table in red. Okay, and we'll already start to look at some like real examples of this today in just a bit. All right. Any questions? Yes. Yeah, sure. Let me explicitly make this really obvious. Okay, what I'm gonna do, I'm gonna redefine table B, and I'm gonna change the first column from X to F. Okay, so table B. So you can see the column name is now an F instead of a Z, or sorry, F and Z instead of X and Z. So if I wanted to merge them, so I'm just copy and pasting my previous one exactly. What do you think is going to happen here? So we have an error now. So let's read what this says. Error in fix.by. By must specify a uniquely valid column. There is no column called X now in table B. So it doesn't know what to merge on because that X does not exist anymore. So you can still merge tables with different names. And the way you would do it within the merge is with this additional sort of modification. By dot x. Oh, that's just my cursor. And comma by dot y equals f. So that's what the by dot x and by dot y stand for. It's just pointing you to the corresponding columns in your x and y, your table A and your table B. If they have the same name, you can just say by equals, and if they have different names, you can specify. So now, if I run this, everything breaks. This is forbidden technology. We're not allowed to show you this. Don't worry, I came prepared. Great, or not. It really is forbidden technology. Okay. This is new. Okay, what the heck is going on here? Well, of course. Okay, let's continue on here. So if we look here at our inner join, we should have the same thing. Okay. It's pretty common to do this. It's fairly rare for your like two data sets that you might get from completely different places to have exactly the same name. So yeah, handy to know the by.x and by.y shortcut if you don't want to like rename the columns in your table. Okay. Any questions about that? Or other questions? Yes. Oh, okay. So basically, in the default, you have an all equals false, which basically tells you which one of these four you're going to do. So I'll just write it over here. So this is all equals false. Outer join is all equals true. Right join is all dot y equals true. And left join is all dot x equals true. Yep. Okay. So the next thing we're going to talk about is, yes, okay, reshaping. So there's two types of formats that you can have when you are displaying your tables. So we'll go through that right now. Erase all of this. So you can have wide versus long. So these are different sort of data formats. So in the wide, this is probably what most people are kind of used to. In Excel, for example, you typically see data formats in this way, where essentially each record equals one row. And so this ends up being something like each variable is stored in a separate column. Okay, and so this I think is what most people are used to. But we're going to start talking about formatting your data in this long format way, which will be especially helpful for lots of different types of visualizations. Okay, and so in here, variables are grouped into a single column with categories. Okay, this set of definitions is somewhat abstract. So let's take a look at sort of a practical example of these. Okay, so I'm going to copy and paste. I can find my mouse. Here we go. So I guess this is going to be our first use of a non-base function. So let me walk through kind of what's going on here while you guys go ahead and sort of copy this code. So the first thing, actually, before you're even able to run this library function is if you don't have this package, you have to install it. So I'm going to write out the code for how to do that. So this can be kind of your primer for installing packages as well. It's pretty straightforward. It's just something like this. Okay, so let me grab my little pointer over here. Okay, so here, install.packages with the name of the package. It has to be in quotes because it's not an object that it recognizes yet. So this will install this package for your R, and then to load that package in a particular session, you say library with the name of that package. So the reshape package, or reshape 2, introduces two functions that we'll use called melt and cast. And those two functions are what allow us to go between wide and long tables. So if anyone has problems with installing the package, just let me know. Otherwise, we can see what's happening here. So this is a table that I'm making. It's just like everything else we've done so far for creating a data frame, with one exception. You guys will note that there's this additional option at the back here called check.names equals false. The reason for that is R does not like it when you have column names that are numbers like this. It will actually modify them a little bit if you don't have this. Basically, what we're telling it to do here is we're saying, don't check the names. I'm happy with the way they are, even if they're numbers. So that's the one slight difference in there. So let's take a look at what this table is. So this is an example of a wide table. And this is something that you can imagine seeing in Excel. This is basically first column, state, California, Texas, Florida. And then in each corresponding year, 2010, 2014, 2018, it's just giving the population numbers for each of those corresponding states, right? So hopefully you guys can all kind of visualize this and similar types of tables that you might use in Excel. So we're going to transform this from this wide format table into a long format table. Okay, and the way that we do this is via a function called melt. So you're like melting the table, I guess. Okay, so this will look like, so the first bit of it is I need to input what table that I'm working with. So it's just state populations.wide, comma. I'm gonna have an ID variable, and that's gonna be the column state. Okay, I'm gonna kind of just run through this really quickly, just so you kind of see what's going on here. So I'm just gonna go ahead, hit enter, and we can look at how a long table looks in this sort of practical example. Okay, so the table has now been rearranged, and you can see that instead of the 2010, 2014, 2018 columns, it's changed it into these columns here. I can see here that the second column represents my year, and then my last column represents the population. So when you melt, by default, it's going to name those columns variable and value. But we can specify in the function, if you actually want to specify the names, you can do this, variable.name equals, right? So our variable is the year, so I'm going to call this year. And our value.name is equal to, we can see that the third column called value is population. So I'm going to call this population. So I'm just going to run that again. And you can see in the console that same thing, except this time I have specified the names of the two columns. So you can see here what I kind of mean by this description, right? If each of the years represent the variables that correspond to a specific population, I've now grouped all of those variables into a single column called year in this particular case. Any questions about that? Yes. Yes, exactly. Okay, and so again, we'll see why this is useful in a little bit, but the way, okay, if you're starting to think about how you might do some sort of like visualizations, right? Let's suppose, okay, let me do something like this. Let me just give a brief insight to why this is useful. So let's say year population. So suppose you make a line graph, for example. You can essentially specify each line as a record, but then you'd have to do it 3 times, right? You'd have to do it either for every year to plot those points or to specify for every state. And once I group them in a long format, I can just call that column and allow the code to do this for you instead of doing them sort of one by one. You can imagine, like if I have many, many years, or if I have many, many states, doing it by a specific state or year is going to become a lot more of a hassle. Okay, so that's just kind of a preview of what we're going to do in a second. I will say that you can also move back from a long table to a wide table. So let me show you how to do that really quick. And there are some instances where this might be useful. Although I will say that I definitely do melt a lot more than cast or decast. I guess is the new version of cast. So same type of thing to go back from a long to a wide, where I specify, so the first entry here is the table which I want to go from the long table, which I want to transform into the wide table. And then it gets a little bit different. So here, what I'm doing is I'm telling it which columns to spread out back into the sort of column names, which is going to be on the right-hand side of this squiggle, and then which columns to keep as its own column. So here, it'll be state on year, and then the value variable I call is population. So if I do this, uh-oh. What did I do? Oh, 2 commas, yes. Okay. And if I look at this, we've now transformed back into the wide table format. Again, I think using cast is a lot rarer because typically data sets that you work with or get online are typically going to be in the wide format. And then you will usually melt that to transform it into a long format. Okay. Any questions about that? Yes. Yes, okay, yes, okay, because that's because you need to have this package. So again, um, so when you have R, it comes with a whole bunch of functions, but people have added functionality. That's one of the big strengths of R. It's all sort of open source and you can make your own functions and packages. And so in order to use those non-base packages, you have to download them ahead of time. So that's line 14 is how you download them. And then once that's done, line 15 is how you load that package into a particular session. So if you try line 14 and 15, you know, without the pound symbol, that should work. Okay, and actually, I'm going to talk a little bit about these. But in the meantime, go ahead and download and load in these packages. dplyr, data.table, and reader. And I guess we might as well do ggplot too. Okay, so go ahead. You have to do the install that packages for these guys if you don't have them already. Sorry, what was that? Okay. So let me talk about these guys for a second. Okay. That screen is not being, okay, cool. All right. So data.frame. So this is our base table structure in R. The data frame is kind of a nice sort of default option, but it's actually a fairly inefficient way of holding data and performing operations on it. And even not even necessarily getting to really big data sets, you'll already start to run into performance issues and functionality issues with it. And so I actually suggest to kind of immediately move away from it and use some of the more popular alternative packages. That way, you don't have to go through a lot of the sort of hassles related to data frames and then sort of jumping on board one of these new packages. So that the two alternatives that I'm going to suggest are the two most popular alternatives to data frame operation. So one is data tables, and the other is dplyr, which uses these tables called tibbles. And they both have their strengths and weaknesses. I am most used to using data tables, but at least for today, I'm going to try and offer a sort of view of how to do things with both of them so people can kind of choose what they would like to do. So in the data frame, we're used to something like this, right, where we have this row column type of thing. With data tables, which I'll denote as DT, the way they do this is I, J, by, and some other stuff here. So this does everything that you can do here. So most of the stuff in I, right, is our row filtering, which we've talked about. And then here, so the difference with this part is that in the second entry here, you're mainly just calling columns in the data frame, but in the data table, you can actually do calculations and make assignments and that sort of thing. Again, I'm going to show with some practical examples sort of how to do this in a second. And then this, I think, is the most sort of powerful thing that you can't really do at all in the base version, but this is something called group by. So if you are a little bit more advanced in Excel, like this group by is kind of what you would think of as the operations that you typically do with a pivot table. Okay, so for those who know how to do that in Excel. Dplyr is a little bit different. So this, it can do all of these things here, but the way it does it is a little bit different. So it chains functions together. So there are things like filter, arrange. These are the most common ones. Select, mutate, select, mutate, summarize, and group by. I think the common argument here, so data tables, I think for most things, the performance is going to be a little bit faster and more efficient. There's a lot of like arguments about which ones might be faster at certain things. You can look up like benchmarks if you want. It's not really that important. But these are both appreciably more efficient and faster than data frames. And I'm not just saying like that to save you half a second or something like this. Using these packages could actually make a really sort of meaningful difference in the time it takes to do something. A lot of people say that the syntax here is a little bit less intuitive. It's more compact, whereas this one you can see kind of more what you're doing. But I think sort of quickly jumping on any of these, it's pretty easy to get a handle of what's going on. Okay. Any questions about this? Okay, so we're going to just jump right into showing some examples of this. Is anyone having any issue? Oh, yes. Are you able to like use those? Yes, you are. So yeah, this is kind of a interesting concept. So dplyr is part of this larger universe of things called tidyr, this like tidy universe, which is this set packages that let you go beyond what you would do in base. And so these operations are all things that you can do on like table-like objects. The sort of go-to for dplyr objects, like the table object is called a tibble, whereas this is straight up just called the data frame. But you can do these operations on, or sorry, data table, not data frame, but you can straight up do these operations on data tables as well. But this stuff only applies to the data tables. Yeah, again, I think this is all kind of ethereal, right? But let's kind of see exactly what's going on with some examples. So I'm going to load in these packages. Hopefully everyone is able to install them and load them in. I'm going to go ahead and do that. So I've loaded in all of these packages. Okay. Let's talk about file management for a second. So hopefully everyone has downloaded those files that I mentioned on the Canvas announcement. So there should be 2 files. And we're going to go ahead and try to load the first one in, the coronavirus_db, coronavirus database. So there are functions in R that will let you read in these tables. And actually the base function has one, data table has one, dplyr also has one. And we're going to look at all of those, how to do all of them in just a moment. But you need to point your software to the right location of those files. So any session kind of works in some kind of directory working space, and this is going to be different on all of our computers. Okay, so the way that you look at the working directory is you say get wd parentheses. So currently my session is running on users Alan Jen. And if I were to call to read in a specific file, that file has to be in this folder. Otherwise, it's just not going to know where it is. Okay. But that is not, in fact, where my file is. So you can do that manually with a function called setwd, but in the Sublime user interface, it's actually a little bit easier. So on the bottom right-hand side, one of the things that you can do is you can go to files. And so everyone needs to do this and go ahead and navigate to the folder where you have your 2 files downloaded. So I'm going to go ahead and do that on mine. So mine is in Dropbox here. Classes. Lecture 3. Okay, and so once you've navigated there, you need to say, this is the location that I want to be working at. And the way you do that, I believe, yeah, okay. So right here, so once you've navigated to the right folder where you have your 2 files, so you can see them right here, and right here. These are my 2 files that I want to be working with. So you click the little settings cog here that says more, and click set as working directory. And that's actually going to execute the command. You're going to see it in the console show up when I click. So if you want to do this manually, you can do this as well, where you say set work, WD stands for working directory, and you just point to the right location. So here, when I say read a specific file, it should, it will be able to locate it because it's contained in the directory that I'm currently working in. So I am going to do this. I'm going to copy and paste this in, and we'll walk through this, but I need to go ahead and run this first because it's going to take a while. And let's walk through this. Okay. So I mentioned that data frame, data table, and dplyr have different ways of loading in the data. So the base version uses something called a function called read.csv. So that reads in a comma separated value file, which is what we have here. And what you can see is that I've done, I think we did this before, right? Where I'm doing a timing. So I want to see how long it takes to read in this file. And so here we can see that using the base version of R, this took about 9 seconds to run. So the next two, so I loaded that in as a data frame. So that's got the .df here just to indicate that it's the data frame version. I'm going to load it in as a data table as well, which is .dt. So it's going to be the same data, but loaded as a data table. So let's run this guy here. Actually, I'm going to run all of them. Oops. Okay. And what you can see, so the data table uses a function called fread, and then dplyr uses a function called read underscore CSV instead of .csv. So we'll see, you can see that the data table took 1.3 seconds instead of 9 seconds. And the table, or the other dplyr version took 2.4 seconds. Okay, story time. So when I was in grad school, I didn't know about these two. And I was working with this big DMV data set from Pennsylvania. And it literally took me, it was like a 15 gigabyte data set, and it literally took me 3 days to load in the data using read.csv. And it was a pain because if anytime I wanted to do anything, I had to be super careful. If I messed anything up, I'd have to clear everything, reload it in, and it would take 3 days. So I literally spent probably maybe like 2 months of time kind of waiting around for my data to load over the course of my sort of graduate school. Having to kind of load in the data so many times. And then in my 4th year, I learned about data tables and fread. And when I tried to load my data in using fread, it took me about 2 minutes instead of 3 days. So this scales extremely non-linearly, is way more efficient, and learn from my mistakes. Don't use the base version for, at least for loading in data. And I'm going to recommend for most other things as well. Okay. So these really are just miles ahead in terms of efficiency. Yeah. Yes, sorry. Okay, let me, you want me to move up in the worksheet or in the console? Okay, the worksheet here. Yeah. Where's my mouse? Okay. Yeah, so I'm gonna so what I'm going to do right now is go, oh, yeah, go ahead.
For the last one, it is not giving me the time difference, it's giving me columns and rows and columns.
Yes. So you'll see here, this is what you're talking about, right? This thing, parse with column specification, cols,
No.
they count, no?
It just says rows and a number of columns, 6, and then column specifications with a line, and then delimiter with a comma in post. And then under that in red is CHR 2, BBL 3, date 1.
It's not this. And you're loading in this data set, coronavirus DB.
Yeah.
What happens? So does it finish loading in? Like what happens if you do covid.tb and hit enter in the console? Does it return something like this?
Yeah.
Okay. I'm not exactly sure. It might be like a versioning thing. But as long as you're getting this sort of table, we should be okay. Okay, so we've loaded in the same data set 3 times using 3 different techniques. And what I'm gonna do now is I'm gonna walk through some of the different things, some of the parsing tools that you can do in sort of all 3 categories to kind of show you how to do them and the sort of performance differences between these. Before we do that, actually, I want to show one thing that we haven't looked at before. There's a nice little feature of RStudio. So here in the data, you can actually kind of look at the data in this like Excel type of form. I don't actually use RStudio, so I'm kind of less versed and familiar with doing this, but what we can see here is that if I click on a table, it's going to pull up a new tab. This is why I need this. It's going to pull up a new tab at the top here, and you can see what this data looks like. Okay, so what is this? This data set is a table of coronavirus infections and deaths since the start of 2020 all the way till, well, it's a continuous thing. If I downloaded it like a couple weeks ago, so this goes through like mid-March or end of March, something like that, of this year. And you can see that it's broken down by county. So in each row, we have the date of the record, the county, the state. So the FIPS is an official US Census denomination for a particular type of location. The first 2 digits, I think, typically is the state. And then the last couple digits are an indication for the county. We'll show how to break that down in a bit. And then the last 2 columns are the number of cases and the number of deaths. Okay, so that's just to give us a, yes? To use the which function? Oh, no, that should be native to RStudio. Oh. Was that the problem? Yeah. Okay. Yeah, let me know if it's still not working, but yeah, that could be it. Okay. Yeah, so typing view, I guess, lets you do this. And I'll always encourage people to do this, right? Like you want to get a sense of what's in the data set that you're working with. So this is a way that we can do that and quickly get an understanding of what's happening. Okay. There are a couple useful functions that I think we've talked about a little bit already. So summary is one of them. So here, this gives me summary statistics, right? So min, median, mean, max, first quantile or first quartile, third quartile of my data. And it tells me what these other things are. STR gives me the structure of my columns. So here, I can say, these are integers, this is a character, so on and so forth. And I think we had mentioned this on the very first day of class, but I can look at the number of rows in this table. So there are 2,327,037 rows, and there are 6 columns. If I look at the first one, the date column. So this column, so the 2020, 01, 21, these are just characters. However, let's say you wanted to like plot it out by date, right? If you are just plotting characters, that on let's say your x-axis, that gives you these sort of discrete character values. You don't know if they're supposed to be in some type of order or anything. So we can actually have a date format, which is something that exists in R. And so what I'm going to do first is show you how to manipulate a column. And this is something that you can do in all 3 of these packages in a different way. So let's show how to do that. So changing format to date type. And this is how you would do things like creating a new or overwriting an existing column. So you don't have to do this. I'm going to wrap everything that I'm going to be doing inside of a function called system time to measure how fast it is. So what I'm going to do is I'm going to call the column covid.df. So we're working in the base package right now. I'm going to call the date column, and I'm going to apply it to this function called as.date, which will transform these characters into a date time format. And that's going to replace the existing column covid.df $date. Okay, so this is something that we've done already. So I'll go ahead and run this. So now I'm going to show you how to create a new column in data tables. So the intuition should build off of what we've been doing so far. So remember, right, procedures in the base version with row and column, we follow that same thing here, but I'm now able to manipulate columns directly in here in my sort of square bracket thing, where traditionally this would only be for referencing. Now I can do it to do manipulation. So here I'm going to do something to the column. I'm going to make a column called date, and the way that you do that is with a colon equals, which means I want to make a new column, or I'm going to replace an existing column. And so this is going to be as, oops. Okay, so if you recall, everything in the base data frame has to be in quotes. But in data table, anything within the square brackets referring to your data table object, you can do it without quotes, and it will know that this is referring to a specific thing. So this is referring to the column, the existing column, and this is referring to the new column that you want to make, and you can do that without quotes. Okay, so I'm going to run this, and it's actually something interesting. This is pretty unusual, and I had to kind of look into this. Specifically for this, you can see that it's actually pretty slow. It's almost as slow as the base version, and usually these types of operations are much faster. And it just happens that as date, there's a particular sort of bottleneck when it's doing in here. So this is pretty specific. You don't need to actually worry about this particular nuance, but I did want to kind of look into it to see why this was happening. So there's this bottleneck in converting the character to POSIX IT, which is the date time format, which you can solve like this. So again, don't worry about this line. You don't need to, this is a pretty unusual thing to happen, but basically what I'll show you is data tables really are faster. Oh, I need to, I think this is in another package. Sorry, one sec. Again, you don't need to do this. I'm just going to add in. Just for demonstration purposes. I need to reload the original guy. Yeah, okay, so usually it's more like this. Okay, so data table is going to be light years faster. Just so happened that there was one particular thing going on with this function. But okay, don't need to worry about that. So the last one that we'll do is with dplyr. So that uses this function, which I guess they call a pipe, percent caret percent, which tells you all the following things. Please do that in whatever specified order to the original object. And I guess it's intuitive because you can chain a bunch of these together. So in this case, the way that you modify a column is with the mutate function, and we're going to do date is equal to as date, like so. Kind of similar. These are all kind of doing the same approach here. Okay, and also pretty fast to do this. And so we've modified the date column sort of 3 different ways. Okay, let's take a look at filtering rows. Okay, actually, any questions about this or confusion so far? Yeah.
For me, the data frame and the TV are taking the same time.
Interesting. Are they both really fast or are they both really slow?
15.7.
15.7 seconds for both. That seems slow for the dplyr. Are you calling different objects? Well, you should be using .tb for the mutate, but you should use .df for the base one. So check that. The other thing is that if you loaded them in, when you're loading them in, the base version uses a .csv and the dplyr uses _csv. So if you didn't do that, you might have loaded this in as a data frame, in which case some of the operations might be a little slower. Okay. We're gonna do some row filtering. So let's take a look. Oh. Okay, I'm gonna ask everyone to use one more package. Sorry, it was the one that I had before. So library lubridate. Working with date time formats kind of sucks in everything, in any sort of programming language. There are a lot of ins and outs and little nuances to them. Lubridate is a package specifically meant to handle date time issues and to be able to do certain things with date time, which make it just slightly more convenient. And so one of those, for example, is this year function that I'm calling, which lets you take a date time and extract just the year out of it. So that's why you have to use this. So sorry, one more package to install. Basically, what I'm gonna do is filter to a specific year. So here, okay. So who can tell me what this command does?
It should get you all records where date is equal to 2022.
Close.
The year.
Yes, the year of the date is 2022. Yeah, exactly. Yeah, so basically, we're applying some kind of filter to our table to extract a subset of that table, and that subset is everything within year 2022. I'm going to add something to it. And COVID.df $county equals YOLO. Okay, what is this thing that I just typed? Yes. Yeah, exactly. So it's just going to look at records within YOLO. If I hit enter right now, what do you guys think is going to happen? It's going to error out because it's extra. Well, will it error out? Let me see. Yeah, it will. The base version is extra sort of persnickety about your commas. So those are row filters, and we have to indicate that as such by going to the end here and adding a comma. It's a very common error. I still make this all the time, although with data tables, it just kind of knows that you're doing rows first. So data tables, you don't need a comma, but it's generally good practice to do it anyways. Okay, so now if I run this, it's going to return something here. I'm actually going to do this really quick just so that we can see it in the viewer. Okay, great. Okay, so the date starts in 2022, January 1st, going all the way down. Let's see, how far do we go? We go to March 20th. Okay, so that's when I downloaded this data. As we look through this again, so I wasn't that specific about these two columns at the end. So what do you guys notice going on here? What do these columns mean? Does anyone know what the population of Yolo County is? What's that? 1 million? 220,000. Okay, sweet. So 220,000, if we look at the cases in each day, it's 23,000-ish, right? Up to 27,000. So was 10% of the population getting infected every single day? No. Okay, so what is this column? Cumulative. Yes, exactly. And same for deaths. So you might not have noticed that when the first time we looked, but we're doing this kind of like closer examination. Okay, so now we have a better sense of what this data is telling us. Let me go back here. Okay, so we are going to, we're going to mess with that in just a second, but let me first show you how you can filter this data in the other alternative means. So data table, super similar, but slightly easier. Year, date equals 2022, and county equals YOLO. So it's almost exactly the same, but you can shortcut this where you don't have to call out the entire column. If you just refer to this date column and county column, it will know that that is what you're talking about in the data table. You can't do that in the base version. It will say, what is this date you're talking about? Or what is this county you're talking about? That's not an object. So I don't know what you're referring to, whereas data table does know. Yeah. So you don't need quotes for your column dudes, but this is an item that you're looking for. within the column. So that does need quotes. So you're going to see if I'm going to hit enter and it works, even though I didn't put a comma at the end, but it's good practice to do that. So I'm going to put a comma here. And it gives you the same thing. Okay. And the last one for the Tibble is different. You use filter. What are we filtering? The object. Oh, whoops, sorry. Oh, no, that is right. COVID, TB, comma. So then year, date equals 2022, county equals, oops, YOLO. So here you can just separate them out by commas. You don't have to put and you put each thing that you are parsing. So if I run this, it will also give the exact same information. So 3 different ways of doing it in each of these packages so that everybody knows. Okay. So now that we've looked at it and we have this better sense of the data, what if I want to create a column? What if I want to create 2 columns in my data set that refers not to the cumulative cases, infections, and deaths, but I want to look at the daily numbers. So someone walk me through in English, not in code, how you would think about going about doing something like that. Okay. So I'm going to be a machine now. And you need to tell me very specifically what to do here. So let's pull this up. All right, so let me just kind of scroll down somewhere. Okay. I assume that you mean subtract the previous row for like cases or for deaths, okay? All right, so I'm gonna do 3 minus the last row, 15, and I get negative 12. Is that what you wanted? All right. More specifically, tell me what to do. Okay, so I wanted to just do 1 county at a time, you're saying? Okay. So let me just do something like this. Actually, why don't we just pull up that view that we had before? So let's say we wanted to do it for, okay, I'm going to pull up YOLO County. Okay. So what do I do? So I say equals YOLO, and then you want me to do this number minus this number to get the daily cases, and then this number minus this number to get the daily deaths, right? Great. So I do that, and then I do the same thing for the next county, and then I do the same thing for the county after that, and so on and so forth until I go through all the counties. Okay, so this is where we start getting to leverage some of the real powerful things in here. Like imagine doing this in Excel. You could do it, and actually if you're good at Excel, it wouldn't be that complicated to do, but there's a little bit of manual work involved. You have to know what you're doing, and it will take a little bit of time. Yes.
How would we
specify what the daily cases are for January 1st?
Yeah. Because if you subtract away, you want to say this row minus this row, right? And so what happens for this row minus a non-existent row, right? Yeah, good question. So you can assume there's generally two approaches here. You can assume that the cases before are 0, in which case you're going to have a sudden jump at the first one. You're going to have 23,200 cases on January 1st, which probably isn't correct. The nice thing is, in this particular case, you can't always do this. This contains the records to the beginning of the coronavirus. So we know that that assumption is true, is actually probably going to be true if you do it all the way to the beginning. But more generally, the way this works is that there's going to be a function that does this thing that you guys are talking about called diff, which does this minus this, this minus this, this minus this, and so on and so forth. And at the very first entry, it's going to drop out your January 1st. Okay. So if you have 1,000 records and you use the diff function, it will return 999 records. Okay. I mentioned what a giant pain this would be to do in Excel. And that holds true for what a giant pain it would be to do in the base version of R as well. Okay, I'm going to copy and paste how I kind of figured out, or well, not figured out. This is kind of how I would do it if I had to use the base version of Excel, or not Excel, of R. So don't copy this down. This will get posted online if you want to take a closer look at what's going on. But to do it in the base version of Excel, there's probably a faster way to do this. In R, I keep saying Excel. But let me just kind of briefly describe in English what's going on here. I'm going to create a data frame that I'm going to like hold. It's this like marker data frame. And then I'm going to walk through all of the counties, basically like what you guys were describing in English, right? For each county, I'm going to loop through it. And I'm going to create the thing that I'm holding, which is filter the row by county. One thing that I'm not sure about is if when you do the diff function, it has to be in the right order, right? So I'm going to do this to put it in the right chronological order. And then I'm going to use this diff function, which is what I was saying, we'll subtract the last thing. So I'm going to do the cases daily, deaths daily. I'm going to add the 0 at the beginning so that it's the same number of rows. And then I'm going to put that into my giant one that I'm holding. And then basically you store that in, and then you repeat, store it in, repeat, and you go through this whole thing, and it generates daily deaths and daily cases. I'm not even going to run this. It takes like a couple minutes, and it's a giant pain to do. There might be faster ways of doing this in the base version, but there is a reason why people have migrated to using these two guys here, because it's way, way faster and way easier. Okay, so daily cases and deaths for data tables. Okay. I guess we are actually not going to get to the plotting stuff. All right, that's all right. Okay, so what I'm gonna do is I'm gonna first order by dates, just to ensure everything is in the correct chronological order in the rows. Okay, here, when we are doing multiple things in the columns area, remember in the base version, we use C to reference multiple. In data tables, it uses list instead of C. That's the default. And there's actually a shortcut. Instead of typing out list, you can just put a period there. And so that's what I do for my data tables. If you're confused about that, the period before the parentheses just refers to list, and that's like a data table specific thing, shortcut. Okay, so what columns do I want in this new table? I want the date, I want the state, FIPS, cases, and deaths. So those are all my sort of original columns, and I still want them in the new data table, so I'm going to call them. And then I'm going to make two new columns, cases daily and deaths daily. Yeah, so you'll notice something slightly different from the column creation that we talked about before. There used to be a colon. That refers to the creation of like a specific new thing where you wanted, yeah, this part gets a little bit confusing. This can also make new columns. We'll put it this way for now, okay? And we're gonna define these columns within this column area. Here's my cursor. All right, here we go. So cases daily, it's just gonna be zero diff cases. And here it's gonna be zero diff deaths. Okay, what is this? So I'm defining a column and it's gonna be filled with zero diff cases, and I'm putting the zero up front instead of just doing diff cases because the exact problem that you were pointing out where the first one's gonna get dropped, so we'll have one less row and we want it to be able to match up. So in the original state, we're just gonna put zero, which actually should be accurate for this, right? And the last thing, the really sort of nice, powerful part of this, instead of having to write this giant for loop and doing this procedure over and over again, I can write by equals county. Okay, so any operation that is happening within this stuff that I'm specifying, you know, give me these columns and then perform this diff function. I can do any other sorts of things in here as well. Right at the end, I have this by, which means do it for different, like the different categories in this group. Okay. So you can see going back to the wide and long format stuff, right? That's one of the powerful things you can do is when you put all those variables together, you can imagine a different structure of this table. So this table is already in the long format. You can imagine that each of the columns is a county, right? That would be the wide format. But in this case, it's all been put into a single column, which lets you do stuff like this. I can say by equals county. And if I run this, it'll give you, we look at this here, I now have daily cases and daily deaths in each county. Do notice that there sometimes are some negative numbers, and that's as a lot of the records true up certain things. And so it is possible to have that in this particular data set. Okay, last thing for today, we'll look at how to do this for dplyr for the Tibble. So you do a pipe, and I say, I want to group by county, and then the operation that I want to do is mutate, which creates new columns. So cases daily equals 0, diff cases, and deaths dot daily equals this. And if I run this, oh, I need to save it. Or is it saved? I'm actually not sure. No, it's not. Okay, so I have to do. Okay. And now we can see the Tibble as well should have everything. It'll have my cases and deaths daily. Okay. So I think that is where we're going to end for today. I didn't get to everything that I was planning to today, so we'll continue to try and fold in some of the R tutorial stuff as we go through some of the sort of regular data analysis lectures moving forward. But what I'll do is I'll post the sort of complete set of notes for things I was planning to talk about. And then as we roll out through the future lectures, we'll cover what's in those notes as well. Homeworks have been assigned. So you should be able to access the first one in Canvas already. And the first homework will be due at the end of the day, next Thursday. So you should have like 9 full days to work on it. Okay, any questions before we end? All right, thank you, everyone.